Hello everyone, welcome to Civil Prep. Okay, so uh, in today's session, we'll be looking at case studies, which is our flagship program. Case study at the rate 1000. And under this, we are undergoing the cases of geomorphology. Okay, so we are looking at cases and case studies of the various geomorphologic events, the landforms, uh, the various activities which are taking place over the Earth's crust or the interior of the Earth crust. We are looking at them and we are trying to understand that how these cases will help us in understanding our subject, that is geography optional, in a better manner, how we can improve them, okay, improve the subject, how we can include the cases in the answer writing, how we can have a better management of the subject with respect to this initiative. Okay, so in the previous part, we have already seen various cases and case studies with respect to geomorphology for geography. Okay, so in this session also we'll be looking at certain cases from the perspective model series laws from those perspective. Okay, so let's start. The first case here we have, that is human induced mental flow due to RLC desiccation. Okay, so this is one of the topic for us today. You might be aware about the RLC. It is one of the most important sea in the Middle East. Okay, so we will be looking at the map of the RLC. Okay, so here we'll be seeing that this is Kazakhstan. Okay, here we have Uzbekistan. Okay, below it we have Turkmenistan. Okay, so this is our condition here. Now, under this part, what we'll be saying that we have RLC, which is present between Kazakhstan and Uzbekistan, almost at this point. Secondly, we also have the presence of Caspian Sea. This Caspian Sea is present in this region. So this is Aral Sea and this is Caspian Sea. Now, when we look at this two important parts, two important regions here, we see that we have uh, also a river system, two river system, which is quite important for us to understand. The first river system which we have here, that is the Amudarya, and the second river system which we have here, that is the Amusar. Okay, so here we have one river. Okay, this is Sardarya. Okay, and here we have another river at this point. So this is Amudarya. Uh, Hello Priti, welcome to the session. So actually I was not aware when you joined. Okay, so I just started. Okay, so you were still seeing it from starting. You can unmute and answer. Okay, let's move ahead. So what is happening here? You might be aware about the news. In last 25 years, okay, the water in the RLC, it has reduced more than, it has reduced by more than 90%. So this is one of the case where this reason for this water reduction, it is river interlinking. Okay, it is one of the part, river interlinking. Number two, the increase in settlement in the region. Number three, industrial activity. Okay, in the number four part, in the recent times, we see that it is also climate change. So these are the certain reasons which have resulted into the reduction in the RLC's water content. Now, what is this case is about? So this was the earlier view of the RLC. Okay, so here we would have seen that the water content was here. Okay, now the water content is reduced. So because of the reduction in the water content, okay, in this lake, it has resulted into the change in isostasy. Okay, here the pressure from the interior of the crust, it has changed here, and we know here that there is presence of asthenosphere in this region. Okay, so what have happened in the next step? Okay, what have happened here? We will see that there is a phenomena of isostatic adjustment has taken place, because of which this region it has uplifted. Why that so? Because the magma from asthenosphere, it has come out and it has filled this region. Okay, it has filled this region and it has uplifted this region. So we will be seeing here that under the new condition, the water is present in this region. Okay, and there is a upliftment of the region has taken place. So this has happened over the isostatic adjustment. So this is one of the important part which has occurred in the real-time condition in the last 25 years. Okay, so when we talk about the isostatic adjustment, we have two important theorists. Number one, we have Airy, and number two, we have Pratt. So when we talk about Airy, okay, Airy has given one concept with respect to uniform depth with, no, it is uniform density with varying depth. And Pratt has given us the concept of uniform depth with varying density. Okay, both the conditions can be seen here like this. So this is the density, here it is uniform. Okay, and here we see that the depth is different. Okay, so this is Airy's concept. While in this part, we'll be seeing that the density here, it is changing, but there is presence of level of compensation. This is actually level of compensation, and this is Pratt's view. Okay, so with this we can understand here the isostatic adjustment, the basics. We can see that what is happening at the RLC region where the RLC is located. So this is one of the case, the first case, that is human induced mental flow due to RLC desiccation. Okay, so did you got this case, Priti? Is it okay? Either you can unmute and speak, or you can reply via message. Okay, great. Now let's move to the next part. Okay, now one thing I want to tell you here, that the uplift which has taken place here, okay, the uplift which has taken place, it has been confirmed by NASA. Okay, and this is happening almost around 2 centimeters per year. Okay, this is happening by 2 centimeters per year, and this has been confirmed by Grace satellite. Grace satellite data. Okay, so this is one of the important part, which is quite important for us to, which we can apply in the form of case study here. Now, next topic here we have with respect to mitigating sinkhole hazards which are intensified by climate change. Okay, so here when we talk about sinkhole is one of the landform which is associated with karst topography. Okay, so this is associated with karst topography. Now, what is happening here? Because of climate change, what changes we have seen here? There is, in certain regions, there is extreme rainfall. Number two, the drainage is poor. Number three, there is excessive groundwater extraction. Okay, so because of these conditions, what we see here that in this particular region, there is presence of aquifers. Okay, there are aquifers are present. So these aquifers, they are basically consisting of certain water resources, that is groundwater resources. Okay, so this is groundwater part here. Now, what is happening here because of the excessive extraction of groundwater system, the poor drainage system, and extreme rainfall? This is resulting into the increased leaching of the ground, and it is resulting into the increased formation of sinkholes. Okay, we have seen that for the karst topography, there is also similar kind of stages which have been provided by Davis. Okay, there is initial stage, there is youth stage, there is mature stage, and there is old stage. Okay, so the same conditions are present here. Okay, so the sinkholes, they are majorly formed in the youth stage. Okay, and here we'll be seeing that the majority, the structure is quite important here. Okay, from the trio of Davis, that is structure, process, and time. So here we need the structure part is also quite important, which consists of limestone, dolomite, kyanite. So these are certain rocks which are associated with the karst landform. Okay. Now, what is happening here that because of the increased rainfall, the poor drainage system, and the excessive groundwater extraction, here we are seeing that the sinkholes, they are increasing in various regions of the world. Okay. Now, if you want to see where this phenomena is taking place, number one, it is taking place in Florida, which is present in United States of America. Okay, so here more than 400 sinkholes, it has been appeared and reported in the year of 2024. Okay, and this was reported during the hurricane season. This report is given by an OAA. Secondly, we have Mahabaleshwar Plateau in India. Where Mahabaleshwar Plateau is situated? Are you aware about it, Priti? Where is Mahabaleshwar Plateau situated? Maharashtra. MH stands for Maharashtra, right? Yeah, it is situated in Maharashtra. You might be aware about in the Satara district in Western Ghats, okay, where this Mahabaleshwar plateau is situated. So here in the case of India also, we will be seeing that there are new sinkholes. They are emerging. Now the Mahabaleshwar plateau of India, we will say that it is majorly made up of basaltic rock, okay, which is part of Deccan plateau. Okay, so this here will be also seeing that there are various fault mountains are also present. Okay, fault mountains are also present here. So here we'll be seeing that this is one of the case, one of the condition. So here we can see that the sinkholes, if we look at the sinkholes, okay. So initially we'll be seeing that the sinkholes, they will be having such kind of topography. But after certain time period, they will be converted into a huge hole. The huge holes will be converted here, and there will be merging of the holes, which will be resulting into the formation of uvalas. Okay, this will again result into the formation of underground caves. Okay, after certain time there will be collapse of this roof also, and it may result into the formation of the cairns, or we also called as lapillis. Okay, so in this way we'll be seeing that there is the evolution of the karst landform is taking place. And this is happening because of the river or the groundwater system. Okay, this case is okay, Kriti? Okay, now let's move to the next case. What we'll be doing here actually, uh, we will be going a bit fast because we need to cover a lot of case studies in a single day, because we need to achieve a target of 1000 case studies by the end of August, because mains will be there in 20, I think it is starting from 22nd. So after that, there will be mentorship sessions, there will be tests. So we have to complete this by 20th of May. Okay. Now, moving to the next case here. The next case is based on application of GIS, that is Geographical Information System, based logistic regression for landslide, susceptibility, mapping. Okay, so this is the third case. Now, this case is quite important because in the year of 2024, we have seen one of the question which was based on mapping. Now, mapping, if we look at it, is one of the part of cartography. Okay, it is part of cartography. And mapping, we will say that it is majorly based on the quantitative revolution. Okay, quantitative revolution. Under the quantitative revolution, we have locational analysis, which basically includes the working of map. Okay, here we use two concepts. One is chorology, which is placing of the various events over the time period, and next is chorography, that what is the current graphical representation of that particular region. So this we will see that this is temporal scale variation, and this is spatial scale variation. Okay, chorography, it is more important, and chorography is majorly for mapping, and chorology, it is the integration of mapping and the recent data here. Okay, so this is the basic which we can understand here from this part. Okay, now let's move to the next part. Now this mapping part, it is applied over the region of Himalayas. Okay, Himalayas, it is under the zone 5 of earthquake zones, which is provided by Bureau of Indian Standards. Okay, so it is coming under the zone 5. Okay, so we are trying to develop a GIS based model. Okay, this model, it is, as we have seen, it is called as logistic regression. Okay, this model is called as logistic regression, where we'll be integrating the various factors like slope, aspect, then we have lithology. After this, we have rainfall. The next we have NDVI. Okay, along with land use. Okay, which will be providing us a statistical framework in the form of map. So we will see, we can also see this from the systems perspective. So this is logistic regression. Okay, here we have various variables as input, and in the output we are getting map. Okay, so all these are variables here. Okay, so by this we will be able to understand the hazards and disasters. Okay, hazards and disasters, they can be understood in a better way in the Himalayan region. Okay, it will also help us for the early warning system and pre-disaster planning. Okay, so this logistic regression model will be seeing that it is provided by Osmo and Lemisho. Okay, so these are the model providers. Okay, along with this, we'll be also seeing that theory which has been provided for the landslide. which is provided as a threshold theory. This was provided by S.A. Shum. S.A. Shum, he was belonging to non-cyclic school. Okay, he was belonging to non-cyclic school, and here he is giving this particular theory in terms of resisting forces and driving forces. Where the energy is trapped in a particular geomorphic region, where the energy is trapped in a particular geomorphic region, and when this threshold is crossed, it results into the creation of cracks and fractures. Okay, threshold may also occur over a slope region, so it will result into slope failure. Okay, so cracks and fractures and slope failure, they will result into landslide. Okay, so this we can apply here with respect to the conditions as we see in the Himalayan region. When we talk about the Himalayan region, we have already discussed about it. Okay, it is tectonically active. Okay, next thing we'll be seeing that there is a subduction is still going on. The Indian plate, it is still getting subducted under the Eurasian plate. Okay, this is part of asthenosphere. Okay, so here the districts where we can see that this the application has already taken place. The application of model number 1, Uttarakhand, Joshimath. Okay, so here we are able to identify risk belts on map. Okay, this is also applied over the Kodagu region of Karnataka and Kerala. Okay, where we see that the monsoon and pre-monsoon rainfall, it is resulting into landslide. So these two conditions where we say that this logistic regression has been applied, and it is helping us to understand the system of the landslide in a better way. Okay, so this is how we can use this case, okay, of the landslide mapping. Okay, this model, the theory of Shum, okay, the threshold theory, we can apply it here. Okay, any doubt in this case? Is voice clear now, Preeti? Okay, I think there might be certain disturbance at that point. Okay, so is this case, you got it? Any doubt in this part? Okay, logistic regression. Yes, we will understand this part. Basically, logistic regression, it is a model which predicts landslides. Okay, and this model, it has been applied recently in the Himalayan region. Okay, now there is something important about this model. Okay, it is basically using certain variables in input, which is used for developing map. Okay, for example, slope, aspect. Okay, along with this, we see lithology, rainfall, then NDVI, also land use or land use pattern. Now uh, you might have went to any mountainous region, either in Himalayas or in Western Ghats, or you might have seen. From where are you, Priti? Which state or which region? Haryana. Okay, so Haryana we have Aravalis, but there is just an extension of Aravalis, so I won't call it a mountain. But have you visited any mountainous region? Okay, not yet. So if you will go to a mountainous region, for example, last year I went to Srinagar. In Srinagar, I went to the region of the various region. For example, there are कौन-कौन सी जगह घूमने के लिए? Gulmarg, Sonmarg, then Pahalgam. Okay, so all these regions have been visited. So these regions we have to pass through the mountainous regions. Okay, so there is a path and there are various mountains are been present here from where you need to move to the places. Now, certain time here we see that there is landslide occurs. Okay, there also occurs rockfall, then debris fall. Okay, certain times there is soil creep also occurs. Okay, so these are certain events which are taking place in this region. This have been explained under the weathering and erosion. And what we have seen that in the contemporary time, these events they are increasing in the Himalayan region, in the Western Ghats region, and it is resulting into the very high losses of life. For example, in the year of 2024, we see that there is a district in Kerala which have undergone landslide. Okay, I think it was Wayanad. Okay, Wayanad district of Kerala, where almost 180 people have died last year. So this was one of the largest event where in a single event such a large number of loss of life has taken place here. Now, what we'll be doing with this logistic regression? Okay, we are trying to formulate maps which are basically GIS based. Okay, GIS based when we are talking about it is taking data from satellite. But along with this data, it is also taking data from the ground, okay, or from the land from where the data is being picked up. For example, slope, aspect, lithology, rainfall, NDVI, and land use pattern. Okay. So under these conditions, what we are able to do, we are able to not draw maps, we are able to predict regions from where the landslide occurrences they are most likely. So this will help us to understand this part here. Now, about the logistic regression, this logistic regression, it is one of the machine learning tool. Okay, it is a machine learning tool which takes real-time data and convert it into maps. Okay, so this is one of the important part here. And this basically what we say that here it tries to draw. This will be a condition here. There will be certain points will be plotted for a particular region. Okay, so there will be x-axis and y-axis. So here what it will do, it will try to make a map of the region, and here we will see that when the data or the points which are plotted about this region, so it gives us the occurrences of landslide, they will be most likely, and in this region it will be less likely. Okay, so these points they will be plotted with the help of the data, and whatever the points which we are taking up here, this will help us to understand the data which will be taken up by the machine learning process, and it will help us to draw this map. And with this, on the basis of this regression map, we will be plotting points that yes, this is a, for example, uh, let's say this is Himalayan region, this is Uttarakhand. Okay, so what we will see here that these are active region will be plotted for landslide, and there will be inactive regions. Okay, and there will be most likely regions which will be plotted here. So all these regions will be plotted here with the help of the logistic regression tool. Okay, Priti, it is better now. Okay, just give me 1 minute. Now let's move to the next case. Now case number, this is case number 3, I guess. Now, case number 4. Tectonic geomorphology and tsunami risk, which is taking place in the subduction zone. Okay, so this is one of the part here. Now, what is happening in one of the subduction zones of Japan? That there, the zone of the region of Japan, we will see that it is witnessing very high occurrences. There are most likely regions that any kind of tsunami will occur in that region. Okay, so when we look at the region of Japan, we will see here that there is uh, this is the region of China. Okay, here we have Japan. Okay, so there are four island system. Under this part, we'll be seeing that uh, here we have Pacific Ocean. Okay, and in this part here we have one of the region which is Cascadia subduction zone in this part. Now, when we talk about this Cascadia subduction zone, we will see here that it is an active region. Now, we need to understand this with respect to plate tectonics. Now, what is happened? This is the Asian plate or Eurasian plate. And this is the Pacific plate. Okay, this is the subduction zone. Okay, this is Pacific plate. Now here what we will see that this region of Eurasia, this is under water. That is Pacific Ocean is present here. Now what is happening here? There is presence of asthenosphere. Okay, under the asthenosphere, when this Pacific plate it is subducting. So with the subducting plate, there is certain sediments and water. It is also getting subducted, and this is resulting into the increase in pressure because of the presence of water. Okay, there is the melting point of this rocks, it declines and it results into the formation of magma. Okay, it has formed cracks and fissures in the Eurasian plate, and this has resulted into the formation of volcanic island arcs. This volcanic island arcs, this have resulted into the formation of the Japan region. Okay, so whatever Japan region here we are seeing that it has been formed because of the island arcs. Okay, and this part, what we see here, this is the continental shelf region. This is the continental shelf region, okay, of the Eurasian region where the Japan has been formed now here. Okay, so this is the zone which we see that this is the Cascadian subduction zone. Okay, this is Pacific Ocean. Okay, so here what we are seeing that the tsunami in this region, it is quite high. As we can see, the rate of movement of Pacific plate, it is one of the fastest, almost around 8 centimeters to 12 centimeters per year. Okay, so this is quite fast. Because it is very fast, here the plate interaction is very high. Because of the plate interaction is very high here, it is resulting into the earthquakes and the chances of tsunami in this region. Okay, so we are able to understand that what is happening in this particular region here. Okay, we have another plate in this part, that is the Sunda Trench. Uh, this is Malaysia, Indonesia. So here we have the presence of Sunda Trench, which is having similar kind of conditions here. Okay, now when we look at the analytical part here, whenever there is sudden release of energy from this point, whenever there is sudden release of energy, it results into the occurrences of earthquakes. Okay, now when we talk about earthquake, there are three types of earthquakes. Okay, one is shallow earthquake, then there is uh, deep earthquake. Okay, and these earthquakes, they are occurring on the basis of Benioff zone. Okay, they are occurring on the basis of Benioff zone. Okay, there is shallow earthquake, which is almost limited to around 80 to 100 kilometers. Then there is a mid earthquake, okay, which is from uh, up to 400 kilometers, and this deep earthquake, it is ranging from 400 to 700 kilometers. Okay, so whenever this deep earthquake occurs, it is one of the most devastating earthquakes happening over the Earth's lithosphere. Okay, so these things we can understand here by the application of certain models. Models like number one, elastic rebound model. For example, if a plate is bent here, if a plate is bent, so if the plate is bending more, so we can see here the stress accumulation, it will increase. And the characteristic of the plate is that it is quite elastic in nature. Okay, so the more bending will occur here, as the more bending will occur, the more stress will be accumulated, and until a point where the rupture is taking place in the plate. Okay, this stress in the form of energy, it is accumulated, and after that it is released. Okay, so this is one of the condition which the elastic rebound model, which helps us to understand this part here. Okay, then in the next part for the theories, we have plate tectonic theory, where we have continental, oceanic interaction. Okay, under this continental and oceanic reaction, we have interaction. We have convergence motion. In this particular case I'm talking about, we have convergence motion, and in this convergence motion, our lithospheric crust or continental crust, okay, this continental crust, it is not completely inside the ocean. It is inside the ocean, but here it's we can say the continental shelf part. The continental shelf, here there is formation of island. Okay, so according to the case, we can explain this particular condition in quite detail with the help of the plate tectonic theory. Okay, so here we are also able to assess the magnitude of earthquake. This can be understood with the help of the Richter law. Okay, who has designed Richter scale. Okay, then we can also apply here the law of conservation of energy, where the stress, it is getting converted into seismic waves. Okay, so this can be also explained with respect to the law of conservation of energy here. Okay, disaster, we see that the earthquake occurs, earthquake results into tsunami, tsunami creates disaster. Okay, so it is a coastal disaster. For example, we will say that the tsunami of Indian Ocean tsunami of 2004. This was one of the most devastating case of, just give me a second. Okay, Indian Ocean tsunami of 2004, where more than 50,000 people over the world, they have died because of this condition. Okay, then we will see that currently there was a small tsunami has occurred in the Mentawai Island in Indonesia. Okay, also in the Cascadia subduction zone. In a particular year, there are almost 1700 events of earthquakes resulting into very small, we can say the tsunamis develop, but they are not very devastating because their resilience, the disaster resilience, it has improved in the region of Japan. Okay, so this is one of the case which is quite important with respect to the subduction zone. Okay, we can apply certain models, theories, laws here to understand this condition here. Okay, Priti, any doubt in this part? Okay, great. Now, this is one of the important case because every year or 1 year after the another, we have question on either plate tectonic theory or we have question on disasters, hazards, or subduction zones. Okay, so we can apply this case in those questions here. Okay, next question here we have with respect to Valencia flash flooding and its geomorphological consequences. Now, when we talk about the Valencia flash flooding, Valencia it is present in Spain. Okay, Valencia it is present in Spain, and there hasn't been an occurrence of flash flood in the year of January 2025. Okay, so this was one of the largest and catastrophic urban flooding, and this flooding it has occurred because of the record rainfall. Okay, this has happened because of the record rainfall in the January year. Okay, now in the January, if we look at the rainfall conditions, the rainfall it is happening because of for India it is western disturbances, okay, but it is cyclones, which is also called as medicanes in the Mediterranean Sea region. Okay, Mediterranean Sea region. If you look at the map of Spain, if we look at the map of Spain here, we will see that this is the region of Spain, and here we have this is the region of France, Germany, but this is Spain, and this is the region of Valencia. Okay, and this is here we'll be seeing that this is Africa, and this is Mediterranean Sea. Okay, so here we can see that this region it is present in Mediterranean Sea region, and here it is affected or impacted because of the what we call as western disturbances. It is the cyclonic disturbances in that particular region. Okay, now what we will see here that what have been the impact of floods. Okay, this was one of the very important part. Okay, in India we do not see this news very frequently, but from the global perspective it was a very big event. Okay, because the city was impacted because of flash flooding. Okay, uh, the region was submerged for around 1 meters around. Okay, and in certain areas it was more than 1 to 1.5 meter, which have resulted into the loss of lives also. Okay, so the impact of flood will be seeing that it has resulted into rapid runoff. Okay, then there was fluvial overflow, then modification of channels, also modification of urban drainage pattern. Okay, now here we'll be seeing that it was alteration has taken place here, the modification of channel in terms of the alteration of sediment flow. Okay, and this has also resulted into the leaf breach. Okay, you might be aware about uh, the floodplain region. Okay, in the floodplain region, we have this is the total, this is the river area, and this is the total floodplain area. Okay, in the floodplain area, we have leaves. Okay, which is basically made up of sediment deposit. Okay, leaves, which is made up of sediment deposit. And this was breached here, okay, because of this flash flood. Okay, now because of this condition, what we see that there is evolution of the channel has taken place. Okay, when we look at this particular region, here we see that it is having one of the important river here. Okay, one of the important river on which the flood has taken place, that is Turia. Okay, the another name for the river, it is Gludaviar River. Okay, so these are the two alternative names for the same river, which is flowing from this Valencia region in Spain. Okay, so here we see the alteration of channel. Okay, then there is also impact on human environment interaction. Okay, there is also, this has also happened because of the anthropogenic infrastructures and activities. Okay, when we try to provide here certain laws, okay, so we can see from the laws, from the context of laws, we have human, sorry, we have hydrological continuity equation, that is water flow is equal to outflow plus storage change. Okay, this is also applied by one of the most important person in the part of channel morphology, that was Leopold. Okay, Leopold, he has given one of the important part that was called as, I'm just non-hydro. Okay, he has provided channel pattern. Okay, and also the plan of river. So this is provided by Leopold. We can use the Leopold condition here to ascribe the condition of flood which is happening because of this condition. Okay, so Priti, is this good? You understood this part? Okay, now let's move to the next case study. Okay, the next case is with respect to the eruption of volcano. Mount Leotobi, Lucky. It is present in Indonesia. Okay, so in January 2025, there was an eruption, okay, which has erupted violently. It was a type of a violent eruption which has affected over 30,000 residents in Flores Island. And name of the mountain or name of the volcanic mountain, it is Mount Leotobi. Okay, we'll be just referring it to the Mount Leotobi here. Now, when we look at the location of Mount Leotobi, we can see here this is Jakarta, this is Indonesia. We have certain islands here. This is Australia. This is Philippines here. Sumatra Island, Australia. Okay, so here at this point we have this island that is Mount Leotobi, and island it is Flores Island. Now, this is an important part. Okay, why? Because here we'll be seeing that in this region we have Indian Ocean, and here we have Pacific Ocean. I'll just highlight it here. Okay, and here we have subduction zone in this particular area. This subduction zone, it is Java Sunda Trench. Okay, this is Java Sunda Trench, and this is, if we look at the plate tectonics of the region, this is Indo-Australian plate. I'll write here Eurasian. Indo-Australian will be better here. And this is the Pacific plate. Here we have asthenosphere. This is a convergence boundary. Okay, the water here we will see that is almost like this here. Okay, so here we see that the same phenomena is occurring here. The magmite is getting melted and it has resulted into the formation of volcanic island arc, and this has also happened over the continental shelf. Okay, this has also occurred over the continental shelf, resulting into the island of Sumatra, Indonesia here. Okay, so here we see that there is when this mountain has erupted, okay, when the eruption has taken place, it has resulted into pyroclastic flow. Okay, then next thing, there was volcanic mud flow. Okay, which has basically altered river paths and buried agricultural land. Okay, and here we'll be seeing that there is formation of new volcanic domes, which is elevating the terrain by almost 12 to 18 meters. So this is also an important event which has taken place here. We see that this is also one of the part of rejuvenation of land. So this is also one of the part of rejuvenation of land which is taking place here. When we look at the theories which can be applied here, okay, number one, the catastrophic model. Okay, where we see that there is high magnitude volcanic events, they are reshaping the landscape in an instant manner. Okay, so this is one of the part of endogenetic forces. Now, number two, we can also apply here volcanic cycle theory. Okay, there is recurrent building, eruption and erosion phases. Okay, then apart from this, when we talk about models, we have one important model here to discuss, that is, it is not happening in India. Volcanism is not present in India. Therefore, we do not have in our syllabus about the volcanic hazard zonation model. Okay, but in the countries where the volcanic activities are quite recently or frequently taking place, they are also undergoing the volcanic hazard zonation model for the prediction of volcanic activities. Okay, so this is one part here which is quite important here. When we talk about perspective, we have cultural geomorphology, which is basically an indigenous perception. Indigenous people perception in volcanic zones, which is also influencing their settlement pattern. Also their activities, or we can say here man environment relationship. Okay, if you want to see certain examples, we can add up here. The indigenous people we can see here, they are called as the name of the tribe is Lucky Lucky. Okay, one of the name of the tribe is Lucky Lucky, and we will see that there are pairs here. Okay, so this is one of the part of this condition. This tribe is living in this area. Okay, so have we understood this part of case, Prati? Any doubt in this case study? Okay, so Prati, what we will do here will be stopping for this session today, and we'll continue tomorrow. Okay, so see you tomorrow. All the best and take care.